UPS, uninterrupted power supply purposes, and to a lesser extent for frequency regulation. But our product is a full 4-hour energy system, which means that it discharges its power evenly at over 4 hours at rated capacity. We do have the capability, using our controls, to extend the discharge period to 8 hours. So the unit that we currently have in the market is what we call our M32. It's an 8 kilowatt nameplate, which discharges over a 4-hour period. So 4 hours of 8 kilowatts is 32 kilowatt hours. It can be, as I say, it can be run using the power electronics over an 8-hour period at 4 kilowatts for the same 32 kilowatt hours. So the energy capacity remains unchanged, but the duration of the discharge is flexible between 4 and 8 hours. So just to reiterate what I've just told you, our flywheels, the Amber Kinetic flywheel, is designed for a 4-hour discharge. Other flywheels, all other flywheels, historically and currently, have been designed for low dollar per watt, very short duration, and very high intensity energy discharge. By contrast, our product is designed for a 4-hour discharge, low dollars per kilowatt hour, so low dollars per energy unit rather than per capacity unit, and for long duration as it's typically defined in utility grids. As I mentioned, previous flywheel technology was less than 15-minute duration, and ours is 4 hours. So this is something that we think of as very exciting and representing a very important change for the market. One of the questions that we often get is, why did we choose steel as the material for our flywheel rotor? And this is part of our secret sauce, if you will. This is part of what we have discovered that has enabled us to come up with this product. And you can see from this chart that of the fibers and, of the materials that are used, in some different flywheels, steel has, steel has the highest strength per cost ratio, which in terms of making a technology which can survive for 25 or 30 years without any problems, this is really what you need to be financially successful. This is a very high-level overview of what our flywheel systems look like. If you start on the left, the sort of brownish rock-looking stuff is intended to represent the ground. Our products are installed below ground. We auger holes, which means we dig a hole with a special type of digging machine, about 7 or 8 feet into the ground, and we place the flywheel in its what we call capsule, which is a corrugated pipe unit that surrounds the flywheel. We place that whole thing under the ground and then contain it with a very strong top. Now, one of the things that is also unique about our product and our approach to flywheels is that we are not attempting to constrain a destructive event, meaning an event where the flywheel breaks apart. We're not attempting to constrain it in the capsule in which we are installing it. One of the things that we learned through our testing of our destructive testing of flywheels was that if you leave the unit to essentially without a constraint, all of the pieces fly off in the horizontal direction. Nothing, there is no linear vertical momentum at all. In fact, it has been the casings of other flywheels which have forced parts to fly upward when there have been the few flywheel destructive accidents. So rather than creating a problem for ourselves in terms of safety by forcing pieces up, we use the earth to slow down any parts that might come apart from a destructive event to contain the unit and create safety. So our underground installation is key to both our safety and our financial competitiveness. As you can see here, the flywheel units are then connected in two ways. One, to essentially our power electronics, our data and control system, which is then connected to the grid, or excuse me, to the network. And the other connection goes through an aggregated DC power inverter, which converts the power to AC at grid connection voltage. I realize I'm going quite fast, so I'll be happy to take questions at the end. And I'm choosing to talk more about certain things and less about others, so feel free to ask questions about things that I don't necessarily bring up in the initial discussion. So for those of you who are thinking about how this technology might be deployed, this is one cut at how we think about market segments and what services we can provide in those segments. So in the utility/independent power producer segment, so very large projects, 10, 20 megawatts and up, the services we see our technology offering include capacity, energy arbitrage, meaning storing power at a low price period of time and discharging it back into the grid at a higher price period of time. Ancillary services like frequency regulation, transmission and distribution deferral. We've seen cases already where by putting our storage units at the end of a line, the utility can defer some upgrades to the transmission and distribution system that they would have otherwise had to perform. And then solar and storage, and I'm sure that's of interest to many of you. We're also servicing the microgrid market and have a number of projects under development in various microgrids around the world. And for that segment, we believe that our strongest services are capacity, energy firming, and backup power. The energy firming meaning if there's a reliance, for example, on photovoltaic generation in the microgrid, and there's a dip in the output, a short-term dip in the output, we can firm that dip and try to keep the grid balanced, the microgrid balanced. And then lastly, and for microgrids, lastly, serving as a backup power. And then the third segment that I've got showing here is commercial industrial. So these will be behind the meter. And we're getting a lot of traction in this segment. The demand reduction is particularly critical in many parts of the world. I'm not sure about how the tariffs are structured in India, but in the places that we've operated so far, many of the commercial and industrial customers are facing very significant demand charges and are taking steps to try to reduce those demand charges where possible. In many cases, our technology is able to provide that demand charge reduction directly or to provide backup to that demand charge reduction. So if you're trying to achieve it by some other method, but that other method has some kind of a shortcoming for some short period of time, then we can protect the demand charge reduction. And again, energy firming and backup power. Here's what we think of as our key advantages over batteries. no degradation in power or in energy. Now, for those of you who are familiar with lithium-ion systems in particular, you know that every couple of years you have to replace or add on new battery units, new battery packs to maintain the initial capacity and energy or power and energy capacity that you originally purchased. There is no degradation at all with the Amber Kinetics flywheel over a 25, 30-year period. It's almost immeasurable. A third very critical advantage is that there are no daily cycling limitations, which means that you can charge and discharge our technology as much as you want in any given day. You can also charge and discharge partially so that you can be charging and not get to full charge. You need to go into discharge mode. You can do that. You can go back. You can go back and forth. You can do complete charges, complete discharges more than once a day. And again, with a lithium-ion battery, by contract, typically, you're limited to one cycle a day because ultimately of this degradation issue. We offer full power over the state of charge range, which is important for certain utilities in that there is no loss of power as you get either to the lower end of the range or the higher end of the range. We maintain our full 8 kilowatts if you're operating in 4-hour mode over the full state of charge range. There is virtually zero variable O&M. The first O&M that we expect on our units comes at 10 years, and it's a replacement of the bearings inside the unit. And also, we're recommending full replacement of the power electronics at that time. But that's it in terms of variable O&M. As much as you run it, you don't get additional O&M obligations or requirements because you've run it more or less. It provides a highly accurate state of charge measurement, which also is important for utilities. With batteries, it's a bit of a guess. You're trying to evaluate a chemical state to determine what state of charge you're at, and it's not completely accurate. Whereas you can, by the RPMs of our unit, which you can measure extremely precisely, you know the exact state of charge of our technology. We operate in a wider environmental temperature range than other batteries. This is particularly important in very cold or very hot locations. With lithium-ion, the hotter that you get in particular, you start to suffer very significant degradation in energy output. So you either have to avoid operating in those conditions, or you have to spend quite a bit of money air conditioning the batteries to avoid this degradation in output, which ends up reducing the efficiency of your system. As I mentioned, our technology is not flammable. There is no fire risk. There are no hazardous liquids associated with our technology. Utilities all over the world are comfortable with rotating machinery. As I mentioned earlier, flywheels and various other forms of rotating machinery have been widespread industrial technologies for 100 years, and so there's nothing that's concerning in that regard to utilities that are looking at our product. One also very nice thing, particularly at the end of the life, or actually two end-of-life features that we're proud of. One is that it's easily recyclable. About 97 or 98% of the weight of our technology is steel, which can be 100% recycled. And I don't think I mentioned, so maybe I'll just say right now, by way of a little bit more description of the technology, the rotor itself, the piece of steel that's spinning inside the chamber that you're seeing now on the slide, is about 5,000 pounds of steel. All of the rest of the balance of system together is about an additional 5,000 pounds. As I say, 97 or 98% of that is recyclable. And we're going to a larger unit I think within the next year. It'll be available commercially. It's what we're calling our M160. It's a 40 kilowatt unit, again, 4-hour discharge to 160 kilowatt hours. I'm not going to say as much about that because the M32 is really what we have available in the market today. Although for those of you who are doing project development or involved with projects that are 2 or 3 years out, if you're interested in this, you may want to think about the M160. And then because of its recyclability, there's a high residual value at the end of life. We estimate about 15% of the original CapEx can be recovered at the end of life through recycling the material. Here's a chart that shows you some of the important specifications of the two technologies, the M32 and the M160. As I mentioned, 8 kilowatt, 40 kilowatt capacity, capacity of 32 kilowatt hours on our current unit, 160 on our M160. The duration is the same, 4 hours, and as I mentioned, they can both be programmed to discharge over as long as 8 hours. Cooling is passive, so it's very low energy requirement for cooling. The temperature range of operation for both units is from -40 C to 50 C on the upper end, with a round-trip efficiency of about 88% for both technologies, measured at the DC bus with self-discharge excluded. Self-discharge is less than 100 watts, and I think I have the more precise numbers in a later slide. I think it's the average so far that we've observed is about 65 units. As I mentioned, there's no daily cycling limitations. The design life is 30 years. Output voltage is 800 volts DC. That goes to the inverter that I mentioned for conversion to the utility voltage. And the response time is less than a second. This is just to give you, this chart shows the hours of operation that we have starting in Q2 of 2016 through today. We're over 20,000 hours of operations. You can see here that about 300 megawatt hours, sorry, about 300,000 megawatt hours cycled. Obviously, rapidly increasing as we increase our installed fleet. We did go through a rigorous third-party validation that was run by one of the major utilities in California, San Diego Gas and Electric, and that report is available. So if you're, seriously interested in having commercial discussions with us, then we can provide that report to you. Or if you're in a regulatory position or you're thinking of financing projects using this technology, that report is available. And you can see some of the results here. I don't know that I'm really going to discuss any of this other to show you just how clean the graphs are. When I mentioned the full power achieved over the full state of charge range, you can see that precisely from these graphs. Okay. This slide is actually a bit old. I apologize for that. Our previous demonstration units were the same form factor, the same rotor, but we spun them a little bit slower. And so they were rated a little bit lower. And in fact, I believe that this is the configuration that San Diego Gas and Electric actually tested. It was a 6.25 kilowatt, 25 kilowatt hour configuration of the exact same unit that is now the M32, which simply has a larger motor generator and spins faster. But you can see that we have basically confirmed, at least as of this test, the specifications which I just showed you on the previous slide. And here's where I mentioned the self-discharge is less than 65 watts. So it's a very, very small self-discharge requirement, and meaning that you get to keep, and use more of the energy for your project's purposes. Okay, here's really, I think, the highlight of the presentation. We have done a very rigorous analysis of what we call the total cost of ownership. So this is a soup to nuts analysis. The capital cost, O&M costs, degradation costs of lithium ion, replacing all the various parts that need to replace over the life of the projects, residual value, all of it. And what we can see through our analysis is that the Amber Kinetics flywheel has the lowest total cost of ownership of any technology that we believe is currently on the market. In this graph, for those of you who haven't seen it or didn't notice, we're comparing flywheels to lithium ion and to flow batteries. The blue line is the Amber Kinetics flywheel. The orange line is the lithium ion, and the gray is the flow battery. Even at 1 cycle a day, our total cost of ownership is below lithium ion. And you can see, I'm not going to say much about this graph. We don't really talk about the inputs to this unless we're under a non-disclosure agreement. So what I tell you now is about as much as I'm going to be able to say, but you can see at least the assumption that we made about the cost of the lithium ion pack, $150 per kilowatt hour, to come to these results. Now this is at a 10 megawatt, 40 megawatt hour size project. Even at 1 cycle a day, the Amber Kinetics technology is cost effective in comparison to the other primary technologies that are on the market. And as you increase the cycling, so if you're in a situation where you're going to want to charge and discharge more than once a day, then our cost advantage starts to grow dramatically. This is, at the end of the day, between the fact that we can meet the technical specifications, which I've showed you, and this financial analysis, this is why we believe that the Amber Kinetics flywheel is in fact a revolutionary technology, as I started off by saying. This is just to give you a picture. This is a rendering. This is not a photograph. This is a rendering of what a 30 megawatt system using the M160, the bigger technology, might look like. It's a total of 6 acres, including the utility interconnection inverter, which is the larger white square in the lower left-hand corner of the drawing. And then you can see the field of the flywheels with other power electronics in the middle. Our first flywheel was delivered to a commercial customer in September of 2016 to Emerging Power, Inc., a developer in the Philippines. We currently have a demonstration project in Hawaii with the Hawaiian Electric Company. One of the reasons why we think that this is really important is that energy storage in Hawaii is expected to be about 20% of grid capacity. So they have a very, very prominent need for storage. We will be shipping that unit to them later this year. And we are in discussions with them and with other entities in Hawaii, principally the U.S. federal government, who has a lot of Department of Defense installations in Hawaii, on several other projects in the islands. And then most recently, something that we're very proud of, We signed a cooperation agreement with NL. I think the press release about this is probably what led to this webinar. Again, we're not going to say too much about it, but we did sign a 2-year agreement with them. And I can tell you they're very interested. So just to close out, show you what the product currently looks like and a bit of what the roadmap is going to look like. You see the M160, so 2019 is when we expect it to be fully commercial. There will be some demonstration units of the M160 available in 2018. You can see that we're changing the form factor, although even though we're getting a 5-fold increase in capacity and energy, the total increase in weight, I believe, is something like 60%, and space requirement is roughly equivalent. So for a 5x increase in the valuable products of the technology, it's less than a 2x increase in the size. And we have plans in our engineering department for larger form factors as well going forward. Thank you for your kind attention to my talk. Here's my contact information. Feel free to reach out. If you do call me, please bear in mind that I'm about 12 hours different than you. So that's why I'm doing it early in the morning for me, and you're doing late in the evening for you on this webinar. So I'm happy to take any questions that people might have. Hello? So the first question that I see here is asking me about limitations in the modularity of the flywheels. And I'm not sure I completely understand the question, but I will try to say what Amber has done about modularity. So that's why one of the reasons why we started with an 8 kilowatt unit, so that it becomes, in terms of the scale of most energy projects, 8 kilowatts provides quite a lot of modularity. And even at the 40 kilowatt size, with respect to a 10 or 20 megawatt project, that still provides a lot of modularity. So if you have something more specific about modularity that you're interested in, feel free to ask. Are there other questions? Okay, so a question, let's see. Okay, so the question is, have you found any suitable project or business cases for the India market? Yes, we have. We think that there are quite a number of business cases. As I mentioned, For those areas in India where there are important or large demand charges on commercial and industrial customers, we may be able to offer a lot of demand charge protection, demand charge reduction, which, depending upon the size of the demand charge, can be very valuable. And in one country that we're working, that's almost the entire business model so far, is demand charge reduction and protection. We also think that in terms of solar plus storage, that there is a big market. We are currently looking for business partners in India, particularly developers who have line of sight to significant scale projects like 5, 10, 20 megawatt projects 2 or 3 years out. And I'd be happy to discuss more details about the business opportunity with those of you who are interested. The next question I got is, how does the flywheel system help demand response? So I've actually done quite a bit of demand response development. I developed this a statewide program in California a number of years ago. And one of the things that we found, and I'm sure that you have seen this in India as well, is that demand response is not 100% reliable. So even if you've contracted with a facility to turn down their electric consumption on a certain kind of notification, grid emergency or high price, or for whatever reason there's a need to reduce the demand, you can't always count on all of your customers to provide the full amount of demand response that they've contracted for. So in that event, when you have a shortfall, you could fire up the Amber Kinetics flywheel, in other words, put it into discharge mode, and you can protect your demand charge or your demand response reductions. So that's a very, very good application for our technology. Okay, the next question that I've received is about the cost and cost competitiveness with other technologies. And unfortunately, I'm not going to be able to get into any other cost information other than what I provided you in the main body of the presentation. We can get into details about costing, but we have to be under a non-disclosure agreement, and we have to have advanced conversations so that we know that we're not just feeding important market intelligence out into the world, that we're actually talking to folks that have real projects. So I'm sorry, I will not be able to answer that question. What is the maximum possible energy which can be stored in flywheel storage? So the maximum energy is determined from Amber Kinetics by the nameplate capacity of our units. So the maximum possible energy storage in our M32, which is our current commercial product, is 8 kilowatts or 32 kilowatt hours. The more important number is really the 32 kilowatt hours. That's the maximum amount of energy that can be stored in a single M32 flywheel unit. Now, there's no limit on the number of M32s that you can put into a sequence and run together. The only limitation there is on the available ground to install them. With the M160, the maximum possible energy storage per unit is 160 kilowatt hours, 40 kilowatts. And again, there's no limit to the number that can be electrically interconnected to one another, operated as a single system. So really the only practical limitation to the amount of energy that can be stored is the amount of ground that you have to install the units. The next question is a very good one, and it's the one place where I think lithium-ion has an advantage to us. The question is, what's the footprint comparing to lithium-ion? And What I can say about that, because the lithium-ion packs and system designs are changing rapidly, I don't know the exact footprint of the most contemporary lithium-ion systems, but we are less energy dense. Our footprint is larger than lithium-ion. So if you are land constrained, in those kinds of applications, lithium-ion is probably advantageous, if that's really the principal concern, is maximizing your storage capacity in a certain land area. Lithium-ion is definitely more energy dense, smaller footprint than Amber Kinetics. All right, the next question is, how long does flywheel take to get to full speed charge from standstill? So once the unit is installed, it's never at a standstill. Our zero state of charge is 3,000 RPMs. So the unit is still running quite rapidly, even when the power electronics will not allow it to discharge any further energy. So the state of charge range is from about 3,000 to 9,000 or 10,000 RPMs. It takes about 4.5 hours, 4 hours and 40 minutes, somewhere in there, to go from zero state of charge, which is 3,000 RPMs, to the full state of charge, which, as I say, is between 9,000 and 10,000 RPMs. The next question, is there any disadvantage of flywheels? So I think the principal disadvantage has already been discussed with the previous question, which is that our energy density is lower than lithium ion. So if you have a space constraint, then you may find lithium ion as a preferred technology for you. Likewise, if you're not able to install the units underground, you don't have ground space available, we have some above ground and safe installation methods that involve building up essentially a berm and installing the unit in that, but it's still, it's not as cost effective as the below ground installation for us. And so it does give us a disadvantage versus lithium. And then the other disadvantage is really more a timing disadvantage, which is that lithium ion just has a much larger scale of activity. They're manufacturing and selling more of them. So they're producing at scale more. They have certain kinds of financial advantages as a result of scale, which we have not yet achieved. As I said, we believe that our economics are still better, even in spite of the scale differences. But I don't want to minimize the advantage of having the scale advantage, which lithium clearly does. Next question is, how much time is required to charge the 8 kilowatt flywheel? As I mentioned, that takes the unit from, if you're at zero state of charge or 3,000 RPMs to full state of charge, or let's say 9,500 RPMs. It's about 4 hours and 30 minutes, 4 hours and 20, 4 hours and 40, somewhere in that range. So slightly longer than the standard discharge, but roughly equivalent. This is an interesting question. How to design flywheel storage system in MATLAB software. And unfortunately, I do not know the answer to that question. That's the first time I've heard it. There is a well-known software, Homer, H-O-M-E-R, which is a microgrid representation software. And we are currently working with Homer, or we've actually just started talking to Homer about incorporating our flywheel storage technology into that program. I haven't heard of anybody trying to do it in MATLAB. If the person who asked this question wants to send me an email, I can see if I can get some guidance from our engineering department on how to do that. Okay, well, I think we've just about reached our time. I appreciate everybody listening so attentively and the very interesting questions. I understand there are a number of other questions which will be sent to me through email, and so I will hope to respond to them in the next day or two. And again, if you have any commercial interest or regulatory or finance interest in our product, we would be delighted to hear from you. You can reach me most easily at the email that I believe you can still see on your screen. If not, I'll say it out loud one time before I drop off, and that is Golove, Golove, at amberkinetics.com. Thanks again. Have a great evening.